write some, I can sling some JavaScript, I can put together Webpack stuff, but if you ask me to host things, if you ask me to spin up the servers, set certificates, things like that, I am definitely out of my realm of expertise. So basically, this is kind of tailored for folks that, you're on a small project, you don't have a dedicated DevOps person to really handle this stuff, and so, instead of kind of having to stumble through this for a couple of weeks, that, the goal here is that hopefully we can provide some sort of loose roadmap for you to reference, use as you see fit, change stuff out, whatever, but just kind of make that road a little more clear.
Correct, yeah. So Melnick will be going over the Webpack portion of it, so bundling the client-side code into manageable portions can be served and hosted on AWS S3 as static files. And then I'm going to be going over the more DevOps portion of the deploying of those files as Amazon AWS S3, as well as the cloud platform of choice, using Heroku. But you could swap any of this stuff out. It's meant to kind of be like a boilerplate / inspirational boilerplate, where if you don't want to use Express, use Koa. If you don't want to use React, use Angular. It's meant to be a starting point. So. And then the end-all be-all of it all being bundling all this under one domain. So like a domain that's actually digestible by a user, so you're not just pointing directly to a Heroku app, because that looks disgusting. So, and then putting together some SSL certs and putting that all in a CloudFront proxy, and see how we go with that today. So.
Cool. All right. So, where did it? Oh. Okay. So. There is a play button. Mediation.
Lower right.
No, that's the switch slide.
What?
I know.
And mirror my screen.
Here we go. I would like to bring you the deck. Okay, well, that's not that helpful. All right. So.
And by the way, we have a repo with all this stuff out there in README documents or in Markdown documentation. So all the Webpack stuff he's going over, as well as the code files, all the examples we're going over are available to look at. So you can pretty much just fork it around with it if you want. We can put it somewhere more to install, but right now we just need it somewhere to share and collaborate between ourselves. So we didn't even try to name it. We just used the normal GitHub. We just named.
Picked a random name.
Didactic Disco is what we got.
Yeah. So for client-side code, I mean, especially rather with the modern web it is today, the web apps are getting larger and larger. It's no longer just a page with some tiny little bit of JavaScript, and it's otherwise just a static document. No, I mean, it's basically we're serving more and more complex web apps. As browsers get more and more features, we're leveraging that. Our apps are getting bigger. There's more and more JavaScript slaying that. Basically, there's a lot of code going into our web apps these days, and so basically, in order to kind of, instead of trying to manage one large JavaScript file that you just kind of throw into the end of your document, that instead you can kind of use a variety of tools to help manage that mess. And so one of them is Webpack, and really. With this kind of more code that's going on in your apps, there's more problems. There's a variety of things that can happen. When I first started doing web development a while ago, that I still have horrible memories of picking up some code base that just had like 2,000 lines in a single JavaScript file. They just called it app.js and threw it in at the end of a HTML document. That was their website. So this is basically taking that leaps and bounds further, and to avoid those problems, all via what they kind of call here this module bundler, but really modules is just code splitting. The idea of just really kind of separation of concerns with your JavaScript that you can kind of tie together using Webpack. So Webpack is like any other tool that does bundling. Browserify, there's a new one, Rollup. Really, there's a ton of tools out there, but Webpack is one solution that it is definitely more of a batteries included approach. The counter to, or rather the yin to the yang of Webpack would be Browserify, where it's very much this is the minimal amount of stuff you need, and it's up to you to kind of layer in the features you need. versus Webpack is very much, again, batteries included. Here's a whole bunch of stuff you can use, and it's basically you can use whatever you like or don't use whatever you like. So with that in mind, that basically with Webpack, it really kind of the philosophy is you define your resources, and Webpack allows you to bundle that as JavaScript and drop it in however you need. And so the way you do that is you basically just configure Webpack, and it handles the rest. And so in light of that kind of configuration, I want to show you guys this bigger. Cool. All right. So to kind of give you guys just a very bare minimum of what a Webpack project looks like. You know, if we have some index HTML that's going to throw in a script, and we have a JavaScript file, and we have some CSS file, that, you know, what you'll see here is that really kind of the important part here is just importing a CSS file. You don't normally do that, but with Webpack you can. So basically what Webpack does is you provide kind of an entry point to your application. In this case, it's going to be example.js. And you tell it, hey, here's what you're probably going to encounter. And what it does is it takes this file, kind of maps a tree of all of its dependencies. So let's say instead of just requiring an example CSS, that maybe I have another couple of JavaScript files as well. You know, examples 2, 3, and 4, all kind of in this in these variety of require statements. That basically this entry point tells Webpack, hey, we're going to start here, and we're going to map this all out, transpile it, and output kind of a bundle. And so the way you do that is by providing a config. And it's really, this is about as bare bones as it gets. You define where you're going to find this entry point, where this beginning bundle is going to be. That bundle is going to do the definitions of what it needs to run. So these require statements tells Webpack, hey, go find these, map out this dependency tree, and then what you do is tell it where to output, and you know how to deal with these things. And so kind of the big one here is this line 1 on this file, the require, right, example CSS. This is basically you importing a CSS style sheet, but instead of like, or rather, you're importing it, but you're basically under the hood having Webpack turn this CSS into a JavaScript module and then load it in. So basically, the way you can tell Webpack to do that is via this loader. And loaders is really the workhorse of Webpack. It's basically loaders are, hey, here's this file type, here's how you deal with it, but what I want you is basically this is going to be something I'm going to be requiring throughout my application code. In this case, you know, I'm just doing a .css. So you'll see here that basically there's a regex here. It's just, you know, .css. This could be whatever you want. You can do a variety of things, but really the most simple thing is just provide a file extension, and then basically say, okay, on any instance of, you know, basically you've encountered an import of this kind, that basically just pass it along to these loaders. And so these loaders are basically just tiny little modules of code that can really run, do a variety of things, but really they're there to provide that process of turning that resource into JavaScript, which can then be loaded as a module. And so that's what kind of this is doing. You'll see that basically what we're doing is we're chaining these together. I don't want to go into too much detail about this, but basically style loader is enhancing what's happening with the CSS loader. And so
this is where the magic of Webpack comes in. A lot of it's piping to another thing, just piping to another thing, just running something after it. But we'll have a larger example next. But
right. And so, you know, if here we are, this is our project right here. I'm just going to npm install real quick. I'll show you guys what we need now. Literally all I have is just Webpack and then those two loaders I defined. So after this installs, you'll see here, like really, I'm just going to run start. And all this will do is tell Webpack to run. And what Webpack does is by default, it looks for a file in your current directory by the name of webpack.config.js. So you can name this to whatever, if you're looking over here, you can name Webpack config to whatever you want, and then all you need to do is provide an argument saying, okay, you won't find webpack.config.js. So here's an argument to basically say use this instead. You just do something like this. Config. So, this should be all done. And so you'll see here that basically, yes, okay, clear. So here's our directory. We have our example.js, CSS, index.html, node modules, and Webpack. So I'm just going to do mcam start. It's going to tell Webpack to run. It's going to find that example.js, and then it's going to see that it has a dependency to example.css. And then because I told it to output, because I told it to output as example.bundle.js, now we see that there's example bundle.js, and if we were to open that here, you'd see a whole bunch of stuff happens. There's a whole bunch of stuff going on here, but this is basically the end result of Webpack going through, loading things as JavaScript modules, and basically bundling it all together. But you'll see here at somewhere at the end here. Somewhere in here is the code I wrote in the example.js. Yeah.
Oh, we passed by.
Oh, I did? Yeah. It was in the very beginning. Oh, okay. Anyway, so that's the most trivial example of Webpack I can give you. So really, to kind of take this to many steps further, what we've done for this example repo is really the big goals we wanted to provide were kind of like a modern developer environment. So things like we're using Babel with I think some of the more recent features. So that means we're using ES6 syntax. We're doing things like destructuring, declaring classes, etc. We have some React in there. Let's see what else. Basically, kind of very bare bones, but what you probably typically run across in your today's modern web app. And so, kind of what I wanted to show you guys is this is taking it 10 steps further than what I just showed you. But again, we have still some of the kind of the basic building blocks. We have our entry app.jsx. We have an output, and we define a series of loaders. And you'll see what's here a little bit different is I'm defining specifically a JS or JSX. Webpack out of the box will support anything with the .js extension, but anything else you have to be specific. So for this, we don't want to just bundle the JavaScript. We also want to turn it from ES6 syntax into ES5 so that all browsers can support it. And the way you do that is via Babel. And so Babel has a loader for Webpack to achieve that. And that's where this Babel loader comes into play. And instead of CSS, we have a JSON loader, and then we've also integrated Sass, and I think we're using a couple of CSS vendor files as well. So what you can do is basically you just define those extensions, and you pass along the loader. And so I'm going to go into super detail about some of these plugins you see here, but again, this idea is you pass a loader to tell it how to deal with this, and really. The loaders can be as the loaders can be whatever you want them to be. There's like 1,000,001 packages you can find on npm to do these things. But those are kind of the core building blocks of a Webpack configuration. And so if we look at this is our client directory over here to the left. That we have a variety of different files. We have some styles. We have some components.
Yeah, and just to drive the React portion, our entry point is at app.jsx. That's the node of our tree. And everything in our React app builds down from there. So Webpack just knows, all right, every single import, just go in and start building that tree out. And then it runs all these loaders against all of the test regex expressions that it hits, either within the actual application itself or potentially some imports it might hit within node modules. That JSON one specifically is for moment.time zone, because we're using moment to do some time-related stuff here. So the React stuff isn't specific at all to this Webpack portion, but just take it away that there's the app.jsx, which is our entry point into our React application. Do the same thing with Angular if you want to, or any other JavaScript.
This is our entry point. We define basically, here's our router, here's our kind of our core root element, and then we tell React to render it to the DOM by via DOM selection. And so we can kind of look at here's our root directories, or rather our root component, setting up a router, and we have our routes. That all we're doing is serving just one route now.
So via that app.jsx, the entire tree is built out.
Yeah, exactly that. Okay, so that's all well and good. So you'll see that basically we define, so we have config.js, right? So this is all stuff going on here. You also see that we have dev and a dist. These are basically our two different flavors for when we're actively developing our application, and basically when we want to package and ship our app in a production-like mode. So basically we have these three files, and so this config.js we're looking at right now is our base config. This is basically all the config that is shared between both environments. That's things like these loaders. We're not going to transpile our JavaScript differently between development and production. We might pass a different variable, environment variable, but the core here, like we're still going to load the files the same like we do other way, so we're going to define those there. Now to show you an example, so in our developer config, all we're doing is basically extending our base config and tweaking any other particular items that we need to. And so you can see a lot here that I haven't really explained to you yet, but really the big ones are some of these plugins, as well as defining a dev tool, and how we want to output. And so dev tools here is basically how you tell Webpack to hold on to source maps of your code. If you're not familiar with source maps, it's basically how you're able to kind of unwind I mean, you guys saw that bundle file. It was like 300 lines, and even though my little trivia example probably was like 6 lines total, right? Webpack does a lot to transpile all of that, and so basically those source maps is how you turn that end result and unwind it back to the individual modules which you wrote. So these are really core for if you're going to open your app in your browser, open up developer tools and start inspecting, throwing in breakpoints. The way Chrome and Firefox are able to do that is via these source maps. So there's a variety of different tools, but this is how you do it. Let's see. So kind of one of the things you'll hear a lot about Webpack, or rather these two ideas kind of thrown together, is something called hot module replacement. The idea is that when you tell Webpack to compile these modules together, turning app.js and down with all these dependencies into modules and then serve them. What you can do is basically have Webpack still running as you're actively developing, and for every change that you save, it finds that module in which it was built from, rebuilds it, and then just throws it back to a WebSocket to your browser, and the browser receives that new JavaScript right away. You don't have to refresh the page to basically see that new functionality loaded in right away.
It does this from memory. So instead of building actual static files, you can actually build all of your files, serve them from a specific location, and have that within memory. And Webpack can instantly redo it, tell your browser to reload, and then the new files immediately.
Yep.
It only builds what it needs to build, because based on the tree structure, it knows I changed this file, everything back below gets rebuilt for the most part.
Yep. Exactly. So yeah. So that's kind of the developer config. You'll see here that here's production config. Really, the big differences here is not these start points, but this endpoint of plugins. And so plugins, I've been kind of sidestepping. Plugins, as it were, plugins is basically extra customization you could do toward the end of your build process. So there's a variety of different plugins you can introduce here, but I'm going to kind of go down the line here. This very first one, we saw that then we had that loader of SCSS or CSS as our file extensions. And what you can do is you can integrate this extract text plugin to kind of customize the behavior, what Webpack does with it. So, again, the default behavior for Webpack is to basically take these resources, turn them into JavaScript, and load them as modules. So what that means is that if you're going to ship that your app, if you don't do any sort of tweaking around this, basically your output from Webpack is just going to be a singular JavaScript file. But you have like CSS and images or whatever else. So where does that all go? It's basically all being turned into JavaScript. So what you can do is if you still want to have like a separate style sheet like you would, if you're going to have example.js, example CSS, and that sort of thing, and basically include them in your index HTML or your HTML document via head and script tags. What you can do is basically introduce the extract text plugin. And all that does is take the end result of all of these CSS and Sass modules, and instead of throwing it back, instead of throwing it into this output JavaScript module, that instead it rips all that out and writes a separate style sheet so that you can include it. So that's what's going on here, and then this input to it is basically customizing the output of the file. So what we do is just take the app, take our version number defined in our package JSON, and define a file name. And the second one is just removing any duplicate instances as Webpack goes through trans file stuff. That oftentimes multiple different packages might use some of the same utilities, and this is basically how you avoid duplicate entries. And this one is basically how you minify all of your JavaScript, so you don't just have one massive thing, but it goes through, minifies and uglifies and all that. And this item here is how you can define environment variables in your JavaScript. So for things like, if you don't want to load developer tools or something like that in your app, when you built for production, when you ship, you don't want to have Redux dev tools opening up. That's really bad. So things like that, you can basically define that via process environment. And then in your client code, you can just define if node environment equals production, you can do your client code there. That's all available there. And so the last one is basically compression. Use running gzip on the output bundle. I know it's all really riveting stuff, but really the end result of all of this is that when I run my script to bundle all my code together and output it, that it's able to traverse all of this. That it's able to traverse that entry point, all of its dependencies, all of the CSS, all of the node modules, like all of those dependencies that I've introduced either from my client code or the node modules and stuff I've imported. That this is the end result. With one command, now I have a bundled JavaScript, I have a bundled CSS, and I have a gzip copy of both of them. So here, I know it's very, very small, but this very first one is 435 kilobytes. And rather the JavaScript bundle and the CSS bundle is 3.5 kilobytes. They're gzipped copies of one another. The bundle goes from 435 kilobytes to 97 kilobytes. So it's all really nice. And after config, it's just an afterthought. I just run one command, it's good to go. And so we're able to see that from here, that all of that gets output into our build. And so here's basically our app, ready for deployment. It's good to go. we have it already built for production, and we have everything in there because Webpack has basically done that for us. And so all that's left to do is now we just upload it to our website, so to speak. And so there's a variety of ways to do that, and Tony's going to kind of go at length with one solution to do that. So again, this is really kind of like really shallow look at Webpack. There's just not the time to really go and like, here's every step of the loader, here's a plugin, things like that. But I just kind of wanted to at least show like what Webpack configs look like and what the general output of these things are. And so I'll have a lot more comments and stuff in the repo that we have linked. But you can use that as a reference. So with that, I'm going to hand it over to Tony.
So with those files there, all you need to do then is to hook it into an actual HTML page. What we'll be doing is there's an Express server loaded in here that will be serving a template, or Jade. It's been renamed to Pug, so they're say Pug or Jade. Got the same thing now. There's some licensing and renaming issues. So all we need to do is serve a template that has a div with the name of ID, was it, or app? It was app, wasn't it?
Yep.
So not going to go into a lot of the server-side stuff too much, but we have a server that we're going to be running. Here's the actual just setup of it. Going down the line, we have an Express server. Passport's kind of in there and ready to go, but if you need logins, you need authentication and stuff like that, you can just put it in there. Not too difficult to actually do. The area for where it can be configured is already ready to go. Just commented out because we don't need it for this situation. We still have a back-end persistence layer just for sessions, which aren't really super important for us. But again, ripping it out was kind of more work than just leaving it in. Most people are building applications that have APIs for a reason, because you're persisting data somewhere. Be you using MongoDB or PostgreSQL, it doesn't really matter from that perspective. Swapping this out with PostgreSQL or going somewhere else isn't too difficult. We run some Express-related work. We set up a proxy to actually access all these bundled files that we have. Will be located on S3. And this proxy is also important because the Webpack dev server is serving all of this code from memory from somewhere else on port 992, or 2992, I believe.
Yeah.
So we're going to proxy to either that locally in our development environment, or we're going to be proxying to our S3 environment for the actual code deployed. So we do the exact same thing for both scenarios, which is pretty nice. And then just fluff. So there are some things within the configuration here for the server that secrets for the server, which can Express, which lets it work correctly during the final setup with CloudFront. One of the main lines is this trust proxy. Whole bunch of comments in here. It's all great, indicating sessions and stuff like that. But this really isn't the entire goal of this. We're going to be putting stuff in S3. We're going to be setting up a Heroku application, and then both be connected and running together. We'll have the app running. So that's the goal here. If you don't like Express, throw in Koa. If you don't like Koa, put in Restify. This really is pretty swappable out. It's the DevOps portion stuff that we'll be going over. So, any specific questions with that? I know we've had a lot of Webpack talk and stuff going on here. So, I can run exactly what we had before. We did the npm run build. We have the files actually created. Oh, it's bundled. And where are all these coming from? We can look quickly at the package JSON here, where all these scripts are located. There's some stuff here for linting and cleaning current folders and making sure stuff's destroyed beforehand. But bundle will run that entire thing that we're performing here. So this created the exact production stuff that we saw before. There's there's three down here that are the important ones that we'll be using, and build's the one for my deployment process. For this deployment process. Starts our server, build creates the actual build files, which takes care of both of our front-end build stuff as well as the server-side build bundling, and then deploying literally just sends it immediately to both our S3 server, our S3 bucket, as well as our Heroku application. Here we see those guys in the build. So where do we want to start? Inside of this repo we have all of the examples, documentation regarding what needs to be done here, and I'm going to skip directly down to all the different steps that need to be done. Our local DevOps setup. You need to set up your local AWS CLI to actually be able to make this occur, to actually push it out to AWS, as well as you need to actually set up Heroku using Heroku Tool Belt. The first step in order to allowing your AWS CLI to actually access and run stuff against your buckets is to set up some sort of permissions. You can use your root account. I highly recommend you use Amazon AIM or IAM to create a user that has authentication to perform this. It's extremely easy to do. I'll continue to zoom in. We need to create a user that has access to perform these duties. So I can go in here, create a new user, give them a name. We then use these security credentials of the access key and secret access key. That's actually, I can't zoom. So the access key is utilized by your local configuration, as well as the secret access key is located there as well. So I'm not actually going to run it locally because that's how when you do things live, everything breaks. But we have the examples right here. You install AWS CLI, and then you run AWS configure. You put both those informations in. You don't actually need to enter a default region name, but it's nice to keep everything in one place. I recommend US West 2 just for Oregon. One of the gotchas here is if you want to use Lambda ever, make sure your bucket as well as your Lambda are in the same area. But choose one, stick with it. And then you don't need to do anything for this guy. Any questions there? That sets up your AWS local CLI to work correctly.
Well, how does it store that information?
How does this get stored?
Yeah, like how does that?
It's in your local, where is it? It's here. Where does it get stored? Nothing's in here. It gets stored locally in the AWS CLI, like configuration. All that information gets stored. So
Okay.
it sets up the authentication with AWS. As far as Heroku Tool Belt, you go there and download it. Click download. You install it. And then you log in. So at this point, you hopefully already have a Heroku account. You just go to Heroku itself and either create an account or log in. After you've logged in, you'll be greeted with a page such as this, where I can zoom in even further. It shows all my apps. I have a few here that are just kind of all over the place, previous projects up here. And if you need to create a new app, you can do it up here. But as far as getting your local set up, do a Heroku login, put in your credentials, use email, password, says you're good, and then we need to make sure that we have authentication actually perform duties to our actual apps. So you can do Heroku keys add. Also do is add your public key to Heroku, letting you be able to work on that. If you need help setting up your public key with Heroku, just do a Google search on it. The first tip will let you do that. All you do is run SSH gen or something like that, I can't remember. Yep. Cool, so that's the local setup. Now we can run all our commands to do deploy. And this begins to get a lot easier from here. So we want to serve our static files in S3. First, we need to get them there. We can upload them manual if we want. We can go to S3. Come on. We can go to S3 and create a bucket and upload them manual if we want. But when we're doing it manually, it gets to be a bit of a pain. You can't integrate with CI servers. You're not really going to be doing that anytime later. So first off, we need to start with creating the actual bucket itself. So I already have one created here that's being utilized for an existing Heroku app, but we can create one fresh here and see this will work. So we need a bucket name, test bucket name, brown bag, bucket, dev, build. Go with Oregon. Oregon is the US West 2. Doesn't really specifically matter, but just for the sake of consistency, using the same region in a lot of areas. And we can create this bucket. Cool. We have a place where we need to put we can put all of our information now. All of the static content that Webpack created can go here. There's one gotcha that needs to be done in order to allow this code to be accessed and run via the Express server through the proxy server. There's some CORS configuration that needs to be added. This can be as open or as restrictive as you want. But right now, this here is a very open example of being able to allow all origins to get these files. If you need more information on CORS, there's some information here that you can click into and go read. But other than that, you're not allowed to run JavaScript from another origin browser to stop you from doing that. That's a huge pain. It's all for your protection. So all you do is copy paste that guy in there, click save. That worked, and that's all you really need to do here. The bucket is set up and ready to go. In order to access this bucket, there is a URL you can go to directly access the bucket here. So our bucket is brown bag bucket dev build. I have a handy dandy. I'm going to copy something here. Handy here. I don't have any files in it right now, but we would simply go to this URL. Brown bag bucket dev build.s3.amazon.aws.com. That will have a direct access to everything in that bucket. Now it's important that it's at the root level because of routes and pathing concerns. So just always make the bucket at the root level. There are comments in the markdown file for this. So when we add our file in for app.version.bundle.js, we'll be able to do / exactly that. Clicking this should give me an error because there's nothing in here. Cool, so we have our local DevOps stuff set up to actually allow us to access S3. We have it set up to us to Heroku. Now we have a bucket that's ready for us to put some files into. So we have a location ready for us to put our files into. We'll deploy to there soon. First, let's get Heroku set up as well. So very simple, you can go in here and create an application. So I'll go in here and create a new app. Not give it a name at all, see what happens. Forgive me. Ancient Falls, good name. Exotic. So we have an application. We have an app in Heroku ready for us to push some files into. And the one key thing that we need to do here is that we need to tell this where our files are in S3. Because remember, it's going to be going elsewhere out to S3 to get these static files. So all we're doing is adding in an environment variable that our Express server is aware of to know where to get those from. That environment variable will change under your development environment, again, to the locally Webpack dev server's in-memory code as well. So it's using that same variable, it's just changing it. So what do we need to do? We can take that exact URL that we had before. So I've already defined that this is the config variable that we'll be assuming to have.
You told your server that's the 1.4?
Yes. I can see that as well by going to my different project right here. It's Doja clock somewhere. Making sure build files are on. One last thing we'll do is, because I did actually have the Mongo stuff available and ready to be working, it'll yell a little bit if I don't add in some sort of Mongo server for it to utilize. So I'm going to add in mlab MongoDB real quick here. All I have to do is click provision and it's done. So again, if you're doing some local environment related stuff or some POC related stuff, this makes it very easy to have a very small to 512 megabytes only, but you have a backend server ready to be utilized here. All right, our app is pretty much done. We can go back to our settings. We'll see that we have the config variables of the build files URL as well as the MongoDB URI. It knows where its persistence layer is. Now it knows where the front end code is. The server just has to worry about doing server-side stuff, serving API code, and also serving our template, which will provide the basis for our React app to hook into. Let's see if there's anything else here. No, nothing else here. Heroku has some pretty cool stuff called pipelines, but that's a little bit extra. So if we go back to our next step, oh man, something happened here. We want to deploy our app. So we already looked very briefly at the commands that are here. We have start, which runs our dev server locally, but we don't want to do that. We want to perform a build, which will get everything bundled in the locations that we want them in. So if I manually delete these right now up here, I'm deleting the build folder as well as the build server folder, just for the sake of showing that they're going to be produced and they're going to exist. If I run npm build, npm run build, this is going to perform perform that exact Webpack bundle for the dist production version of the Webpack, as well as move all of our server-side code, only the stuff we need, into a folder that will be able to be pushed into Heroku. And bam, we got our build. We see app, and we also see our build server, which has three things. A folder of server, which is basically our server folder, just copied it over, as well as the package JSON. Heroku's going to need this in order to do an npm install and install all of our dependencies that are available here, because it needs to get Express, it needs to get Lodash, especially needs Pug. And then a proc file. So if you haven't used Heroku before, all this is saying is when Heroku downloads all its dependencies, installs everything, it goes, hey, run npm run server, which is, again, just another script available in our package JSON. Server just says run our server.js file, which is our hook entry point into Express. Again, this can all be swapped out if you're not using Express, go use something else. But we want an API server that will be able to run, and the server-side server file is our entry point into this. Add .list. Cool. So let's very quickly take a look at how all that build occurred, and then we'll perform a deploy and look at how the deploy actually occurred as well. So in our scripts, this is where a lot of the magic is happening with performing these builds, these bundles, for this part of the DevOps process. So this build is just saying we're going to run a clean, which is let's clean the folders, make sure they're tidy for us, let's make sure that only it's new code that we care about, as well as perform our bundle, which is bundling our Webpack related code front end, as well as our server-side code. So within bundle, there's a little bit more going on here. We're just going to literally run our Webpack config. We have a path to our config.dist.js, and we run it. Webpack takes over from there. We wait till it's done. There's some syntax here. Await is a nice, is it CS7 or CS6? CS6. Essentially just means we're waiting for this promise to continue, complete. If it fails, the whole thing shuts down. After this is successful, we then perform some movement of files. We move server over to server, package JSON to package JSON, and scripts this here, part file to part file. This is just to put only what we need in Heroku, not everything. You can put everything. It's very unnecessary. After that completes, we have the bundle done. We have all of our files located there, and that's what we saw. So our deploy process has a little bit more going on here. Let's start with the upload to S3 because it's extremely simple. There are essentially two lines that need to be run for deploying to S3. These two right here. So the AWS CLI is pretty good. All we're saying is AWS, utilizing the S3 functions, please remove our current bucket, which I'm putting in here as a command, or sorry, putting it as a variable, an argument. So we're just going to say, hey, remove that bucket we just created. We just want to delete everything inside of it. Delete everything inside of it utilizing our cursor. Why? Because we just want to murder everything that's in there. We're pushing new stuff. Secondly, please sync our build folder, this will be the first argument in our command, to this bucket, again, the second argument in our command. And then setting up some just nice cache control headers on this. Public read, everyone can read it, it's accessible to anyone, there's no restrictions there. Cache control just saying, hey, make sure it's good for one day for browsers for the cache controls. This is all that's necessary to deploy to S3. I can run this locally if I wanted without actually using this script, but there's just some nice gotchas here just to make sure that, hey, you actually put buckets in there and stuff like that. Any specific questions about that? We're just copying files in S3. The other portion of that magic is a little more involved, only because Heroku operates off of having you commit files to a Git repository that Heroku manages at its master branch. So you commit files to master, and Heroku sees those changes occur and then does a build. So we need to do exactly that in script form. So we push all of our server-side files into our build server. We create a Git repo. We then actually clean everything in there. Sorry, the comments are here for all of this. The one thing I learned yesterday very quickly was that we fetch the master repository first. We have all of it available. Then we murder everything, except for the Git actual information. We copy all of our server-side code into there, and then it doesn't diff automatically because Git and all its magic. So this is where a lot of the magic is occurring for performing all of that, but it's really not too terrible reading through each line of this. But given time, it's really not super worth going line by line through here. This is performing a Git force push to master on the Heroku branch. I have this stuff hard-coded up here right now for the current application that I was operating on. We could do the exact same up here right now if we wanted to. So let's do that. On our Ancient Falls right here, that's the app name. Where's the URL? Well, we have the Git repository URL, which is, where is that located on here? Under access. Whoa. Right here. There's our Git repo. Those should find somewhere. Where's the website? Well, it's just Ancient Falls 46347 at Heroku app. And our bucket, well, we already named our bucket because this needs to know what bucket we're talking about when it's performing the script. So let's go back to our bucket itself and steal that name from the URL up here. So this entire deploy process can be expanded on to not have this specifically hard-coded, but rather maybe thrown in a configuration file with multiple environments. Each environment is given a variable. You want to deploy to dev, then you look through the correct information and toss it in there. You want to deploy to prod, you can do the exact same thing. Yeah, so we have our Git repo, name of the actual app, the website itself, because it's going to perform a nice request of the website at the end, and what bucket we need to push our files to. So let's see what happens. Because this is where things usually break, because I changed some stuff. So it created a folder, initialized the build server as a Git repository. We then clean everything within there, but ignore the Git stuff. We built our files correctly. We're cleaning up after installing, making sure AWS CLI is installed. We then just immediately, I'll scroll up a bit. Too fast. Right here, we uploaded each one of these files to our brown bag dev build bucket. 4 files, 4 uploads. And then last but not least, we then moved we committed all of our files for the server build folder. Not too many, but just created all those. Now we got Heroku hooked into, and we're getting the log files back from Heroku here, stating, all right, cool, node app detected. Let's start building this puppy. It's going through, did an npm install. Then this is where Heroku's magic takes over, but Heroku will automatically do an npm install every time a hook and every time master's been updated, and it'll hook into that. So I did an npm install real quick for just the dependencies. Build was successful. It's good to see. When it was done, it had 22 megabytes worth of information, and now it's currently deployed. So if we go there, it should work. Let's see what happens. Let's open the app. Look at that. So this is the dumb little app we made. There's actually some fun stuff with it. But these are CSS clocks. There's a Doge in the middle of the clock. It tells your current local time zone based off of your local time zone using moment time zone. Time zone a lot there. And then all the other ones. So we can add in more here. These were kind of meant to expand upon the multiple delivery centers that Slom has. You can add in more as you want. Doing some React stuff in here. And then when it's 4 o'clock at any of these time zones, the clock goes crazy and starts flashing colors. So it was just a fun little thing I did over the weekend, but we wanted to demo that this wasn't just a simple, trivial 2-line app. There was some stuff going on with the actual application itself that Webpack was actually performing to build something. Now, if we take a look real quick at this application, the app was built, we have all the server-side code available and being pulled from a location. Well, we can take a look at that. Let's see how big I can make. Oh man, look at that. Probably the best. These files are coming in from assets app dash right here. So we see we're making a request to Heroku for these files, but we know that these aren't hosted on Heroku. They are being hosted on S3. And how do we know that? Well, first off, we can go here and actually look at those files. Bam. And Heroku is, or not Heroku, our Express server is proxying those for all requests that go to assets. All requests that go to, no, they're fine. All requests that go to assets get proxied immediately over that bucket. So you can add as many build files as you want over there, you'll get them. If you need to proxy other things like static files that may be hosted locally or static files that are hosted elsewhere, you do the exact same methodology here as well. So we have our style sheet at the top, and we have our script at the bottom. Those are proxying through. The proxy code is not that expensive to look at. Just saying for all assets, go here. That's it. So just making sure only GET requests are going there, because we're not doing any API requests directly to our S3 bucket, would you? Then we do have a template that was actually displayed here and actually hooking in our application to div.app. So let's take a real quick look at how that template is being served, because that's what ties both the Heroku side and the build side together in the actual application that's served. So we have a routes pages here. Whenever the user goes to /, just using some configurations here so it's in one place. Whenever the user goes to /, please render our view of the dashboard. A dashboard is just a view, a PUG file, or previously a JADE file, that is giving some HTML markup that'll be created. So we can go over there and look at that view. This dashboard, I'm going into templates too much. We have a base layout that we're utilizing called .pug. It's right next door to this. And looking at this layout, we have a head, and we have some headers that are going to be pushed in here. We have some links that we're going to be putting in here. And here's our div with an ID of app. And then there's some further scripts that are at the bottom here. So this is a generic layout for all different pages that you can create. And then a specific page of our dashboard looks specifically at our assets app style CSS and our assets app version of bundle.js. We also have the nice title clock. So if you had a different single page application that was being created or bundled with Webpack, you can have Express very easily create another version, another template to be served that is not using app, but using app2 or spa2, and you can kind of change the names and do what you need to. This is providing the hook into the site to allow you to actually view the page itself. So any questions there? We had everything deployed S3, and we deployed our code to Heroku, and everything's working. I know that was a lot. Where was the magic? It's all magic. So the implementations aside of the actual code itself, the process makes sense though, right? We're just putting some static files in S3, and we're telling Heroku to update with some server code. Now, performing those deployment duties, luckily there's some example documentation here and documentation in the actual Markdown files here of what's going on with all this stuff. How it's running, why it's doing it, and what's going on here. So there is further information about how this is operating in the Markdown files, as well as the last final step of putting a domain in front of both of these. So you could go to mydomain.com, and you'd be utilizing the Heroku app and performing all of the information, doing everything there. So hopefully Tony's eyes aren't glazed over too much. This all sounds familiar though, right?
Very, very much, yeah.
What did I miss?
I think you got code ship maybe.
Yeah, so in terms of pushing this to a CI tool, there are some instructions here on how to actually perform this. I'm on the page right here, so CI upload via script. On your CI server, you're already performing the npm run build. You're already linting, you're going to be running tests and doing all those sort of things. I only ran npm run deploy. You do the exact same thing on your CI server. If your environment variables are set up correctly and your CI server has the same credentials for its AWS CLI and its Heroku tool belt, you'll be good to go. You just run npm run deploy, and it'll perform that duty. So if you're hooking into all updates made on the branch develop set up the environment variables correctly for that hook, and run deploy script, and that's all it needs to do. So, but this plays very nicely with CI servers. So, if there's any other questions, feel free to ping me. This is good. It's a good template, I believe, for like learning this actual DevOps process and Webpack portion, as well as providing an inspirational and just generic boilerplate to get going on an application. If you don't need server-side related information or an API or anything built like that, you can just use Webpack to build a static application and serve that. You could serve it you could actually serve it directly from S3 if you wanted to. Take this one step further, put an index.html in here, and you're done. You can run your entire just client-side application from S3 if you really wanted to, without any problems. There is, I think, one thing that needs to be set up. You can tell this to be a static application, static website hosting. It just means that it'll look for the index document, and if there's any errors, it'll look at an error document. But other than that, you can run just your core, you can run just your client-side application. There's no server-side components necessary, directly from S3 if you wanted to. Yeah, so I don't know if there's any questions or if anyone needs anything else. Solid?